Good morning, students. Today we shall start with the data warehousing implementation and data mining in continuation with the previous class. So the main objective is define multidimensional data models. Then the course outcome is students should be able to understand, identify the data mining problems and implement the data warehouse. So the table of content is indexing the OLAP data. It means that you are going to index the bitmap indexing or join indexing. So what is this indexing? However, why we need this indexing? What are the different forms of indexing that is there? So indexing OLAP data. So here, when you have indexing, it means that mapping. So here we have bitmap indexing and one more is join index. So what is this bitmap indexing? Bitmap indexing method, which is a popular OLAP product because it allows quick searching in the data cubes. The bitmap index is an alternative representation of the record ID RID list. So in the bitmap index for a given attribute, there is a distinct bit vector BV for each value V in the attribute domain. If a given attribute domain consists of n values, then n bits are needed for each entry in the bitmap index. So there will be n bit vectors. So if the attribute has a value V for a given row in the data table, then the bit representing the value is set to 1. So in the corresponding row of the bitmap index, all other bits of that row are set to 0. So bits, it will be in the form of zeros and ones. So bitmap indexing, for an example, if you take all electronics data warehouse, suppose the dimension item at the top level has 4 values representing the item types: home, entertainment, computer, phone, security. Each value, that computer, is represented by a bit vector in the item bitmap index table. Suppose that cube is stored as a relation table with 1000 rows because the domain of item consists of values. The bitmap index table requires 4-bit vector. So each with 100,000 bits. So here we have a table which shows the dimension item, city, and its mapping to bitmap index table for each of the dimensions. See here you have RID, you have item and city. In RID R1 you have H here. So in the item bitmap index table, if you consider the row R1, the tuple, H is made 0, H is made as 1 because it is present here. That is what is your bit vector BB. It is made as 1 and all other bits are zeros because we don't have value here, right? So same way you are going to represent from R1 to R8 in the bitmap index table. Next, you consider the city bitmap index table. So here in the base table, if you consider R1, in city you have V Vancouver, right? So it is made as 1. The Toronto, we don't have any value, so make it as 0. This is how we are going to represent the bitmap index with zeros and ones, where we are going to have the indexing OLAP data using bitmap indices. So bitmap indexing is advantageous when compared to hash and tree indices. So here it is especially useful for low cardinality domains because comparison, join, aggregation operations are then reduced to have the arithmetic operations. So it substantially reduces the processing time. So bitmap indexing leads to significant reduction in space and input output since the string of characters can be represented by a single bit for high cardinality domains, and method can be adopted using compression technique. So join indexing method gained popularity from its use in relational database query processing. So traditionally you have the indexing mapping done where you have the columns to a list of rows having that value, right? So in contrast, what you have is you have a join indexing registers that we have the joinable rows of two relations from the relational database. For example, if you consider two relations R of RIDA and S of B of SID, it means that R and S are the relations where you have RID and SID are the identifiers, record identifiers, right? Here you can join an attribute A and B. The join index record contains the pair RID, SID, where these two are the record identifiers as I told. So hence you can join index record can identify joinable tuples without performing costly join operations. So join indexing is especially useful for maintaining the relationship between foreign key and its matching primary keys, okay, from a joinable relations. So we have a star schema model of data warehouse which makes join indexing attractive for cross-table search because the linkage between a fact table and its corresponding dimension table comprises the fact table foreign key and the dimension table primary key, where you have a join indexing maintaining the relationship between the attribute values of dimensions within a dimension table and the corresponding rows in the fact table, right? Where you have a join indices may span multi dimensions to form a composite join indices. When you have both, right? So you can form a composite join indexing. We can use this join indices to identify the subcubes that are of interest. Fine. Join indexing, you have an example here. We have defined a star schema for all electronic stores where we have the form sales star. So time, item, branch, location. So dollar sold is equal to sum. An example of a join index relationship between the sales fact table and the location and item dimension table. For example, the main street value in the location dimension table joins with tuple T57, T238 and T884 of the sales fact table. So I will describe that with the example here. See, we have a location dimension table, we have an item dimension table, and in between we have a sales table. So foreign key of the sales table, you are relating that with the or matching that with the primary keys of the dimension table. So main street you have, and then you have T57 which is mapped to Sony. Same way main street, it is mapped to T57, T238 and then T884. T459 is not mapped. When you consider item Sony TV, it is mapped with T57 and T459. Done. So this is what how we are going to represent the join index table based on the linkages between the sales fact table and the location and item dimension tables. So suppose that there are 360 time values, 100 items, 50 branches, 30 locations and 10 million sales tuples in the sales data cube. So if the sales fact table has recorded sales for only 30 items, the remaining 70 items will not participate in join. So if join indices are not used, then you need to have additional input outputs which have to be performed to bring the joining operations of the fact table and the dimension table together. So in order to further speed up the query processing, join indexing and bitmap indexing methods can be integrated to form bitmapped join indices. This is very important. Bitmap join indices. So today's class you have studied indexing, OLAP data like bitmap indexing and join indexing. So session-wise questions like you have defined data warehouse implementation or explain efficient data cube computation or explain the compute cube operator and the curse of dimensionality, explain partial materialization, selected computations of cuboids, explain indexing, OLAP bitmap like you have bitmap indexing or join indexing. They can ask you for 6 to 8 marks in the exam. And then references, these are the references. Textbook is Campbell, the first, second textbook. And thank you all.